In this lesson, we will learn how to obtain the graph of g of x in vertex form from the graph of the parent function. Now suppose we wanted to obtain the graph of the following quadratic function g of x. And suppose we wanted to do it by transforming the parent function. Well, if I start with the graph of y equals x squared, I would have this parabola. Now if I stretch the graph vertically by a factor of 2, I would obtain the graph of y equals 2x squared. But I want to obtain the graph of g of x. So what I need to do is translate the graph of y equals 2x squared to the right 3 units and up 1 unit to obtain the graph that I'm looking for. So this would be the graph of y equals 2 times the quantity x minus 3 squared plus 1. Okay, in this example, we're going to graph this quadratic function here. First thing I want to do is identify and plot the vertex. Notice that the vertex will be at -1, -2, so I plot the vertex here. Now, according to the pattern that we've seen before and in the reflect questions, if I move to the left or right 1 unit, I need to move down a quantity of 3 units. So if I move to the left 1 unit, I go down 3 units and I'm at the point -2, -5. And if I move to the right 1 unit from the vertex and move down 3 units, I'm at the point 0, -5. So I plot those points, connect them, and I end up with my parabola. Okay, now what we're going to do in this example is, given the graph of a quadratic function, we're actually going to write the quadratic function's rule. So a house painter is standing on a ladder and drops a paintbrush, which falls to the ground. The paintbrush's height above the ground in feet is given by the function of this form, where t is the time in seconds since the paintbrush was dropped. Now, because f of t is a quadratic function, its graph has to be a parabola. Only the portion of the parabola that lies in quadrant 1 on the axis is shown because only the non-negative values of f of t make sense in this situation, and the vertex of the parabola lies on the vertical axis. So, since the vertex of the parabola is at 0, 30, I know that I can substitute those values, 0 and 30, into my quadratic function in vertex form. From the graph, I can also see that f of 1 is 14, so I substitute 1 in for t and 14 for f of t to determine the value of a for the function. So this results in an equation that only involves one unknown. So what I do is I solve this equation for that unknown, and I get that a is equal to -16. This allows me to write the complete function rule for the quadratic function, since I now know the value of a, h, and k. So f of t would be equal to -16t squared plus 30. One problem in this reflect question is there's a typo. It should say using the value of t from reflection 3a, not 2a, so it should be 3a. Okay, so the essential question that we answered is, how do we obtain the graph of g of x in vertex form from the graph of the parent function? The first thing we do is identify the vertex h and k. Next, we identify whether the graph will open up or down by taking a look at the sign of a. Then, for the x values h minus 1 and h plus 1, we notice that we must move vertically a units from the vertex. So the corresponding y value in each case is a plus k, and the parabola passes through the points h minus 1, k plus a, and h plus 1, k plus a. And then we finally use those 3 points to draw the parabola.